All right, so moving on to topic 1, Introduction to Earth Systems, lesson 3, the hydrosphere, which will be found on pages 24 to 35 in your textbook. As always, we're going to start with our connected on page 24. So the first thing we need to do is circle the different areas of water in this photo. So we have the ocean area, of course, and then this little lake type of area inside the land that's kind of connected but not. So questions: infer, why is water important to human beings? All living things need water to survive. Human beings need water to cook, wash, and drink. We also use water as an energy resource. So applying scientific reasoning, why is water important to our planet? The water in Earth's hydrosphere interacts with elements in the other spheres. Water helps to regulate our planet's temperature by absorbing heat. The water cycle. So the water cycle, which is a vocab word, is the continuous process by which water moves from Earth's surface to the atmosphere and back again. Through this process, Earth is able to constantly recycle its water. Evaporation. So evaporation is the process by which molecules at the surface of a liquid absorb enough energy to change to a gas. And evaporation is a vocab word, as well as transpiration. Transpiration is water vapor given off through leaves. There are many different ways that water gets into the air to evaporate to start the water cycle. Condensation and precipitation. Condensation is a vocab word, and it is the process by which water vapor becomes liquid water. During condensation, clouds form. Precipitation is also a vocab word. It is water that forms in clouds and falls to Earth as rain, snow, sleet, or hail. Through these three main processes, Earth has been able to keep a fairly constant amount of water in its systems. This means that the water you drink today could have been drank by your ancestors or even a dinosaur. The water cycle, page 26. So this is figure 2. This diagram shows some of the major processes that make up the water cycle. Draw arrows to show the way that water moves through the cycle. Then in the blank spaces, write the process that is at work. All right, so first, down here at the water, we have evaporation happening, and it is moving up. Then we have precipitation, and that is going down. So the rain is coming back down to Earth. Evaporation, the water is moving up into the atmosphere. Down here at the trees, we have transpiration. Remember, that happens through leaves. So it's when the water evaporates through the leaf, and that, of course, is going back up into the atmosphere. And condensation is water going to the clouds and forming clouds. So that's where our arrow should be, and that's the labels we should put in each of these boxes. So make sure you fill that out in your workbook, please. Now it's time for a reading check. Draw evidence. The biosphere interacts with the hydrosphere within the water cycle. Cite one example of that interaction. So the biosphere interacts with the hydrosphere during transpiration. Transpiration is the release of water vapor through plants' leaves. All right, so the distribution of Earth's water. Around 97% of water in the hydrosphere is salt water. That means the remaining 3% is all we have for drinking water. However, 2/3 of the fresh water is frozen. Then almost 1/3 of the fresh water is underground. So only a very small fraction is left for lakes and rivers. Runoff is the process where water that drains into streams and lakes. So process is one of our academic vocabulary words. So it is a process, or a process is a series of actions or operations leading toward a particular result. List some processes you are familiar with in your daily life. So please do so in your textbook now. All right, moving on, salt water. The Atlantic, Indian, Pacific, and Arctic are the different parts of the ocean. Just in the Pacific Ocean is a large enough area to cover all of Earth's land. So water resources, figure 3, most of the water on Earth is salt water in the ocean. So this shows that the oceans are 97% of the water, 3% is fresh water. Of that 3%, 70% is frozen, 29% is underground, and less than 1% is in our lakes and rivers, and that's what we use for drinking water, which is part of the reason why water waste treatment plants are so important. So, reading check. Where is most of Earth's fresh water found? And the answer is that it is frozen as snow and ice, as seen in our figure 3 picture. Surface water. This includes everything on the surface of Earth. So that's oceans, rivers, streams, lakes, ponds, and so on. All rivers start as a trickle of water from a source. It could start as an underground stream, runoff, melting ice. Gravity causes rivers to flow downhill. Tributaries are streams and smaller rivers that feed into a main river. The main river and all of its tributaries make a river system. Watersheds. A watershed is a vocab word, and it's the land area that supplies water to a river system. This is the land where each river gets its water from. The larger the river, then the larger the watershed. So figure 5, page 28, is an example of different watersheds that we have. So it shows that this map shows the watersheds of some large rivers in the United States. Draw a line in the map to represent the Great Divide. Use arrows to show the direction in which the water flows on each side of the divide. So the Great Divide is around here. You should draw your line, and then you need to draw arrows going out each way. Divides. Watersheds will stay separated from each other by a ridge of land. This is called a divide. Streams will flow either way from the divide, collecting into rivers. Mountains are an example of a divide. Water will not flow over a mountain, but it will flow down either side. This runs into streams or rivers. The more water from divides leading to one location will make a larger river. Ponds and lakes. Ponds and lakes form when water collects in low-lying areas of land. Ponds and lakes contain mostly still water, unlike rivers and streams. These bodies of water can be made from the same resources as rivers, so runoff, ice melting, underground streams, or rivers. Lakes can be formed in many different ways. So lakes and mountains. Figure 6. Lakes are important because they hold some of Earth's fresh water. So here we have 2 different images of kind of how lakes and mountains come together, and the divides and that sort of thing. So, a reading check. How do river systems, watersheds, and divides interact? A river and all the streams and smaller rivers that flow into it make up a river system. When rivers join another river system, the areas they drain become part of the largest river's watershed. Watersheds stay separated from each other by a ridge of land called a divide. All right, so plan it on page 29, building a reservoir. So in order to increase the benefit from the water cycle, humans alter it by building reservoirs, which store water. Do some research to help you plan how to build a reservoir in your region of the country. Use the space provided to draw a diagram showing the features of your reservoir. Write out the steps of your plan below. So we're going to do this together. I'm not going to make you do this one by yourself. So we're not going to be researching. We're just going to kind of go over some of the parts of a reservoir. So we're going to start with our steps for our plan. So I will build a dam to stop the river from flowing and build pipes that carry the water to homes and create a system for keeping the water safe and clean. Now to draw the pictures. So we're going to have a river and we're going to block it with a dam. Then that'll accumulate and we'll have a reservoir, which the water will then go through a treatment facility and into our homes. And then the process just repeats. It'll come back from the homes into the reservoir, go to the treatment facility, go back out to the homes, and on and on and on and on. Groundwater. Another large portion of water in the hydrosphere is underground. Far more water is located underground than in all of Earth's rivers and lakes. Groundwater, figure 7. This diagram shows how water travels underground. Add arrows to identify the paths that water takes. So, first we'll do water from the river down to the sand gravel aquifer, so that water moves down, right, which we can see it doing, starting to do up at the top. Then water is also moving down through the rivers and being stored underground in the cracks and pores. Aquifers. So unsaturated zone, when water fills spaces in the ground that contains air as well as water. These layers are not saturated, meaning that they're not filled with just water. Saturated zone, when water is completely filling an area underground. The top of saturated zone is known as the water table. An aquifer is the area below the saturated zone where there are layers of rock holding the water. Remember that aquifer is a vocab word. This provides 55% of the United States with drinking water. So that's where we get 55% of our drinking water. Wells. A well is a vocab word, and it is a hole sunk into the earth to reach a supply of water. So people can get groundwater to drink from an aquifer by using wells. People used to hand dig wells, then use buckets to bring the water up. Now, with modern technology, drilling equipment is used to dig and pumps are used to move the water. Reading check. What is an aquifer? So as precipitation falls to earth, it travels into the ground through small openings and creates stores of water in the ground. The stores of water that are accessible are called aquifers. Exploring the ocean. So the water in Earth's ocean varies in salinity, temperature, and depth. Salinity is the total amount of dissolved salts in a sample of water. The more fresh water that comes into an area will lower that area's salinity. If a surface receives rain, which is fresh water, that will lower the salinity of the ocean in that area. The salinity of water affects how the water freezes. Think, why do we put salt on roads for the winter? So that's part of the reason why here in the Midwest we have lakes that freeze over the winter, right? Because it's fresh water, it gets cold, the water freezes. Salt, however, will affect the freezing temperature of the water because it's now a mixture, which causes it to lower, which is why the oceans don't freeze. That's why we put it on the roads too, to lower that freezing temperature, so it makes it, once it makes it more difficult for the roads and whatnot to freeze over. Temperature and depth. So the surface of the ocean absorbs energy from the sun. Temperatures on the surface vary between seasons and location. The ocean is 3.8 kilometers deep on average. This is twice as deep as the Grand Canyon. As you descend through the sea, the temperature decreases. So here we have figure 8, ocean depth. So we need to draw an X where the ocean temperature is the highest and draw a circle where the pressure underwater is the highest. And then we need to answer the question, in your own words, state the general relationship among temperature, pressure, and depth. So we're going to draw an X at the top of the water where we can see in the image. We're going to draw the circle at the bottom where the ocean floor is. So the temperature is going to be highest up at the top, closer to the sun. Then the pressure is going to be highest at the bottom of the ocean. To answer the question, in general, as depth increases, temperature decreases and pressure increases. Ocean features. Scientists have mapped the ocean floor. They discovered that the deep waters hide mountain ranges bigger than any on land. How can a mountain be so big underwater? The ocean floor includes seamounts, trenches, continental shelves, continental slopes, abyssal plains, and mid-ocean ridges. So here we can read figure 9, pages 32 for examples of each. So the ocean floor, page 32, figure 9. So this is what we were just talking about. The ocean floor has many interesting features. Number each feature on the diagram to match the accompanying descriptions. So we'll start off. 1 here. It is a seamount, which is a volcanic mountain that rises from the ocean floor but doesn't reach the surface. 2 here is a trench. It is a long, deep valley on the ocean floor through which old ocean floor sinks back toward the mantle. 3. The continental slope is the steep edge of a continental shelf. 4 is the continental shelf, and it is a gently sloping, shallow area that extends outward from the edge of a continent. 5. The abyssal plain is a broad area covered with thick layers of mud and silt. And finally, 6, we have our mid-ocean ridges, which are long chains of mountains on the ocean floors. These are areas of constant change. Along these ridges, lava erupts and forms new ocean floor. Reading check. How do the temperature and pressure most likely differ at the top of a seamount and the bottom of a trench? As you descend deeper into the ocean, the water becomes colder and the pressure increases. So the top of a seamount would have a warmer water with less pressure than the conditions at the bottom of a trench. All right, and now it's time for our lesson check. So 1, what are the important processes in the water cycle? So the water cycle includes evaporation, transpiration, condensation, precipitation, and flow of water above and below ground. 2, what are the components of a river system? The watershed supplies water to a river system. A river system and all the streams and smaller rivers that flow into it make up a river system. 3, what are the main features of the ocean floor? Major ocean floor features include seamounts, trenches, continental shelves, and slopes, abyssal plains, and mid-ocean ridges. 4, how does the interaction between the hydrosphere and the geosphere affect the supply of drinking water? The geosphere interacts with the hydrosphere when the soil absorbs water from Earth's surface. This water seeps into the ground where it forms underground aquifers. People dig wells and drink water from the aquifer. 5, create a Venn diagram comparing freshwater and saltwater. So, freshwater, only 3% of water on Earth, and it's mostly frozen. Saltwater is 97% of water on Earth. It's mostly liquid. It freezes at colder temperatures than freshwater. They both are part of the water cycle and interact with other spheres, and animals live in it. And that concludes lesson 3.